Imagine staring into the vastness of space, billions of galaxies scattered like glowing embers against the black void, each one home to countless stars, planets, and perhaps even civilizations. Now, imagine that hidden among these galaxies, a deep, invisible force is at work, one so powerful that it's dragging entire clusters of galaxies toward an unknown destination. A force we cannot see, cannot measure directly, and cannot explain. This is not science fiction. This is dark flow, a baffling cosmic phenomenon that has left scientists struggling for answers. The universe, as we understand it, is supposed to expand evenly in all directions. But what if certain parts of it are moving in ways they shouldn't? What if there's something lurking beyond the limits of what we can observe, influencing the motion of galaxies? And if that's true, then what else could be out there? The story begins in 2008, when a team of astrophysicists, led by Alexander Kashlinsky, was studying the motion of galaxy clusters. They were using data from NASA's Wilkinson Microwave Anisotropy Probe, WMAP, a spacecraft designed to measure the faint glow of the cosmic microwave background, CMB, the oldest light in the universe, a relic from the Big Bang itself. By analyzing how this ancient light was scattered as it passed through galaxy clusters, the team could track the movement of these massive structures across space. What they found was shocking. Instead of moving randomly, as expected from standard cosmological models, these galaxy clusters were all being pulled in the same direction, toward a mysterious region far beyond the edge of the observable universe. The speed at which they were moving was equally astonishing, nearly 600 kilometers per second. That's over 1 million miles per hour, a speed that simply should not exist on such a massive scale. This wasn't just a tiny anomaly. It was a large-scale coordinated movement that spanned billions of light years, a phenomenon so vast that it suggested something incomprehensibly massive was exerting a gravitational pull, something located beyond the limits of what we can see. But here's the problem. We're not supposed to be able to see or feel anything beyond the observable universe. The CMB marks the absolute boundary of what we can detect. Beyond it, space continues, but the light from those regions has not had enough time to reach us. If dark flow is real, it suggests that something enormous exists beyond our cosmic horizon, and it's powerful enough to influence galaxies on our side of the boundary. This raises a terrifying question. What exactly is out there? One possibility is that dark flow is caused by the gravitational pull of massive structures, gigantic cosmic formations that lie outside our observable universe. Some theories suggest that, in the earliest moments after the Big Bang, there may have been regions of space with vastly different densities, some of which evolved into enormous galaxy clusters beyond what we can see. If these structures still exist, their immense gravity could be dragging parts of our universe toward them. But then there's a more unsettling idea. What if this isn't just another galaxy cluster? What if our universe isn't alone? Some physicists speculate that dark flow could be the first evidence of a parallel universe interacting with our own. If that's true, then our universe, everything we've ever known, might be just one bubble in a vast cosmic ocean of realities. These parallel universes, sometimes called the multiverse, could be exerting gravitational forces on each other, subtly influencing the motion of galaxies in ways we don't yet understand. And yet, despite more than a decade of study, dark flow remains an unsolved mystery. Some scientists believe the evidence is compelling, while others argue it could be a measurement error, an illusion caused by gaps in our data. But if dark flow is real, it could change everything we know about the structure of the universe. But here's the biggest question of all. If something is pulling our universe, if this force continues to act over billions of years, what happens next? Could galaxies be ripped away from our cosmic neighborhood? Could entire regions of the universe disappear into the unknown, beyond the limits of what we can ever reach? Or, more chillingly, could we be next? If galaxies are being pulled by an unknown force, the next question is, where is it taking them? And perhaps more importantly, why? For over a decade, scientists have been chasing this mystery, trying to determine whether dark flow is a glitch in our measurements or undeniable proof that something beyond our universe is exerting an influence. If real, it could mean our fundamental understanding of space, gravity, and reality itself is incomplete. To fully grasp the implications of dark flow, we need to understand what should be happening versus what actually is happening. According to standard cosmology, the universe is expanding in all directions, a consequence of the Big Bang that occurred 13.8 billion years ago. This expansion was first observed by Edwin Hubble in the 1920s, when he discovered that distant galaxies are moving away from us. The farther away a galaxy is, the faster it appears to be receding. This is known as Hubble's law. Now here's where things get strange. If the universe is expanding uniformly, then the movement of galaxy clusters should be mostly random, affected only by local gravitational interactions with neighboring galaxies. But dark flow suggests that entire superclusters, groups containing thousands of galaxies, are moving in a single, consistent direction, as if something massive is pulling them from beyond the observable universe. Let's break it down. When scientists analyzed the cosmic microwave background, CMB, the oldest light in the universe, they expected to see minor temperature variations caused by the gravitational influence of galaxy clusters. These tiny shifts, known as the kinematic Sunyaev-Zeldovich effect, occur when photons from the CMB interact with hot gas in galaxy clusters. By measuring these shifts, researchers can determine how fast these clusters are moving. But the results did not match expectations. Instead of random motion, the data suggested that galaxy clusters were moving in a single direction, toward a mysterious, unseen force outside our cosmic horizon. This movement was observed even in regions of space where expansion should dominate, meaning it couldn't just be a local effect. Something enormous, something beyond anything we can directly observe, was causing the motion. But what could possibly be that powerful? Theory 1. The attractor beyond the universe. One explanation is that dark flow is caused by the gravitational pull of structures beyond our observable universe. These structures, sometimes called great attractors, could be massive concentrations of matter that formed before inflation, before the rapid expansion of the universe that followed the Big Bang. If true, this would mean that our observable universe is just a tiny portion of a much larger cosmic structure, one where gravity from unseen superclusters is pulling our galaxies toward them. Some scientists theorize that these megaclusters could be made of dark matter, an invisible substance that makes up 85% of the universe's mass but does not emit light. But how could something beyond the observable universe exert a gravitational pull on us? The answer lies in general relativity. Gravity isn't limited by distance, it's an interaction between mass and the fabric of space-time itself. Even if these superstructures are beyond the range of our telescopes, their gravity could still influence objects within our observable universe. If this is true, then what we call the universe is just a small part of a much larger cosmic landscape, one that we may never fully explore. But there's another, more unsettling possibility. Theory 2. The multiverse connection. What if dark flow isn't caused by a massive object but rather by an entirely separate universe? Some physicists believe that our universe is part of a multiverse, an infinite collection of parallel realities, each with its own laws of physics. In this scenario, dark flow could be the gravitational interaction between our universe and another universe beyond the cosmic horizon. This idea comes from string theory and M-theory, which propose that space consists of multiple dimensions. If these theories are correct, then what we perceive as our universe is just a three-dimensional membrane, or brain, floating in a higher dimensional space. Other universes could exist alongside ours, separated by imperceptible distances in extra dimensions. If two of these brains come close enough, their gravitational fields could influence one another, pulling matter across cosmic boundaries. This could explain why galaxies are moving in one direction, seemingly towards something that we cannot see. But if another universe is exerting a pull on ours, what happens if the two collide? Some scientists speculate that if two universes were to merge, it could trigger a cosmic event similar to the Big Bang, potentially rewriting the very fabric of reality. Others believe that instead of merging, these universes could slowly drain energy from each other, with one universe growing stronger while the other fades. But before we spiral into the realm of cosmic doom, there's another important question we need to ask. Is dark flow even real? In 2013, NASA's Planck satellite conducted a more detailed survey of the CMB, and some astronomers claimed that it did not confirm the existence of dark flow. Instead, they suggested that what Kashlinski's team observed could have been a statistical anomaly. However, not everyone agrees. Kashlinski and his colleagues argue that Planck's data does not directly contradict their findings, but rather indicates that dark flow is harder to detect than previously thought. The scientific debate continues, but one thing is certain. If dark flow is real, it could be one of the most important discoveries in modern cosmology. But here's where it gets even stranger. If dark flow is dragging galaxies toward an unknown region of space, and if this force is powerful enough to influence entire clusters of galaxies over billions of years, what does that mean for our future? Could it be that one day our own Milky Way will be caught in this mysterious current, drifting toward an unknown fate? And what if something is not just pulling us, but waiting for us? If dark flow is real, then the universe as we know it is not behaving the way we thought. Entire clusters of galaxies, each containing billions of stars, are being pulled towards something we cannot see, cannot reach, and cannot explain. But here's the most unsettling part. What happens to the galaxies that vanish into the unknown? To understand the potential fate of these galaxies, and perhaps even our own, we need to consider what lies at the end of dark flow's path. For now, we can't directly observe what's beyond the cosmic horizon. The universe is only 13.8 billion years old, which means that light from regions farther away than 13.8 billion light-years hasn't had enough time to reach us. This creates a fundamental limit, the observable universe. Everything beyond it remains hidden, not because it doesn't exist, but because its light hasn't reached us yet. But dark flow suggests that something beyond that invisible boundary is still affecting us. If that's true, it means our universe is not isolated. It means that there is more, much more beyond what we can ever hope to see. The possible fates of the universe. Dark flow is unusual because it implies a preferred direction in the cosmos, a contradiction to what cosmologists expect. The cosmological principle states that on large scales, the universe should look the same in all directions, homogeneous and isotropic. But if dark flow exists, it suggests that the universe is not symmetrical. Instead, there could be regions of extreme gravitational influence pulling parts of our cosmos toward them. So what happens if our galaxy, or even our entire local group, eventually becomes part of this flow? Scenario 1. The Great Escape 1. Possibility is that the galaxies caught in dark flow are being pulled toward a gigantic supercluster or cosmic void beyond our observable universe. If this is the case, then they may never return. Over billions of years, these galaxies would continue accelerating toward an unseen force, eventually vanishing from the view of future civilizations within the Milky Way. To them, it would appear as though entire portions of the cosmos were simply disappearing. No explanation, no warning, just entire galaxies fading beyond reach, beyond detection. If this process is happening on a massive scale, it could mean that our universe is being slowly consumed by something beyond our cosmic horizon. Scenario 2. A multiversal collision. Another possibility is that dark flow is evidence of a cosmic interaction between universes. If another universe exists beyond our own, and if its gravity is strong enough to influence galaxy clusters within our observable space, then we may be witnessing the first physical proof of the multiverse. But what if these universes aren't just influencing each other? What if they're on a collision course? Some physicists believe that two parallel universes could eventually merge or interact, distorting the very fabric of space-time. If that happens, the physics of our universe could be rewritten, potentially erasing everything we know. It's possible that this has already happened before. Some cosmologists speculate that what we perceive as the Big Bang could have been the result of two universes colliding, releasing an unfathomable amount of energy and resetting everything in the process. If that's true, then dark flow could be the warning sign of another impending cosmic event, one that could create, destroy, or reshape reality as we know it. Scenario 3. The end of our universe. The most unsettling possibility is that dark flow is pulling galaxies towards something far more destructive than a simple gravitational attractor. What if the endpoint of dark flow is not a collection of galaxies, but rather a cosmic abyss? Some theories suggest that our universe could one day experience a big rip, a catastrophic event in which dark energy becomes so powerful that it rips apart galaxies, stars, and even atoms themselves. But what if dark flow is accelerating this process? What if galaxies are being funneled toward an unknown region of space where the laws of physics themselves break down? What does this mean for us? Right now, our Milky Way is not part of dark flow, at least, not yet. Our galaxy is currently moving toward the Andromeda Galaxy due to gravitational attraction, and in about 4.5 billion years, the two will collide and merge. This event is part of the normal structure of the universe. But if dark flow is real, then what we think of as normal may not last forever. Over time, as the universe continues to expand, parts of the cosmos may be dragged into the current of dark flow. That means that entire civilizations, entire cosmic structures, may one day vanish beyond the cosmic horizon, never to be seen again. Could this be the ultimate fate of the universe? A slow, inevitable drift towards something we will never understand? Or could dark flow be a sign of something greater? Some scientists believe that instead of an ominous force, dark flow could represent the next step in cosmic evolution. If our universe is interacting with another, what if that means that one day we could learn to traverse the boundaries between universes? Could we one day reach beyond our observable universe and discover the true nature of reality? Or will we remain forever trapped in our tiny cosmic bubble, watching as the unknown slowly pulls the universe away, one galaxy at a time? Final thoughts. The mystery of dark flow is still unsolved. Some scientists argue that it's real, while others believe it could be an illusion caused by errors in data. But if it does exist, it could be one of the most important discoveries in the history of cosmology. It could reveal the presence of cosmic megastructures, provide evidence for the multiverse, or even hint at the ultimate fate of the universe. But for now, one thing is certain. Something is out there. And whatever it is, it's pulling entire galaxies toward an unknown fate. What do you think? Is dark flow real, or is it just a cosmic illusion? Could it be the first sign of a multiversal interaction, or are we simply witnessing the effects of an unseen gravitational force? Let us know your thoughts in the comments below. And if you enjoyed this deep dive into one of the universe's strangest mysteries, be sure to like, share, and subscribe for more mind-blowing cosmic discoveries. Because the universe is vast, mysterious, and sometimes it moves in ways we still don't understand.